It's a great pleasure to be here in a space filled with wonder, curiosity, and the shared desire to explore the mysteries of the universe. Today, we're diving into one of the most fascinating, enigmatic, and powerful phenomena in existence: black holes. These cosmic giants are not just the stuff of science fiction or theoretical musings. They are real, they are terrifying, and they are reshaping our understanding of the universe itself. Imagine a place where the laws of physics as we know them break down. A place where gravity is so intense that not even light can escape its grasp. A place where time itself slows to a crawl, and space is twisted into unimaginable shapes. This is the realm of black holes, the universe's most powerful and mysterious objects. They are the ultimate cosmic paradox, invisible, yet capable of bending the very fabric of reality. They are destroyers, yet they are also creators. They are the end, yet they may hold the key to new beginnings. Let's start with the basics. A black hole is born from the death of a massive star. When such a star exhausts its nuclear fuel, it can no longer support itself against the crushing force of its own gravity. The star collapses in on itself, and if it's massive enough, it forms a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. This boundary, the point of no return, is called the event horizon. Beyond it lies the singularity, a point of infinite density where the laws of physics as we know them cease to exist. But black holes are not just cosmic vacuum cleaners, mindlessly devouring everything in their path. They are dynamic, complex, and incredibly powerful. They can spin at nearly the speed of light, warp space-time around them, and even create jets of energy that shoot out across the universe. They are the ultimate gravity engines, converting matter into energy with an efficiency that dwarfs anything we can achieve on Earth. The story of black holes begins with the work of brilliant minds who dared to imagine the unimaginable. Over a century ago, the concept of a black hole was first proposed, not as a result of direct observation, but through the power of mathematics and theoretical physics. The equations of general relativity predicted the existence of these strange objects. But for decades, they remained a theoretical curiosity. It wasn't until the mid-20th century that astronomers began to find evidence of black holes in the real universe. One of the first black holes to be discovered was in a binary star system where a black hole was pulling material from a companion star. As the material spiraled into the black hole, it heated up and emitted X-rays, revealing the presence of the invisible monster. Since then, we've found black holes of all sizes, from ones just a few times the mass of the Sun to supermassive black holes, millions or even billions of times more massive. These supermassive black holes lurk at the centers of galaxies, including our own Milky Way. But how do we know black holes exist if we can't see them? The answer lies in their effects on the surrounding universe. Black holes warp space-time, bending the paths of light and matter around them. They create gravitational waves, ripples in the fabric of space-time, that can be detected billions of light years away, and they power some of the most energetic phenomena in the universe, from quasars to gamma-ray bursts. One of the most dramatic demonstrations of a black hole's power came in 2019, when scientists released the first-ever image of a black hole. Using a global network of telescopes, they captured the shadow of a supermassive black hole at the center of a distant galaxy. The image showed a glowing ring of hot gas swirling around the event horizon, with a dark void at the center. The black hole itself. It was a moment that captivated the world and confirmed what scientists had long suspected. Black holes are real, and they are as awe-inspiring as we imagined. But black holes are not just objects of scientific curiosity. They are also laboratories for testing the limits of our understanding. They challenge our notions of space, time, and reality itself. For example, what happens to matter that falls into a black hole? According to classical physics, it's lost forever, crushed into the singularity. But quantum mechanics suggests that information cannot be destroyed, leading to a paradox that has puzzled scientists for decades. This is the black hole information paradox, and it remains one of the greatest unsolved mysteries in physics. Black holes also raise profound questions about the nature of the universe. Could they be gateways to other dimensions or universes? Could they hold the key to unifying the forces of nature? And what happens inside a black hole? These are questions that push the boundaries of human knowledge and imagination. But black holes are not just objects of fear and destruction. They are also sources of incredible energy and potential. When matter falls into a black hole, it doesn't just disappear. It releases vast amounts of energy in the form of radiation and jets of particles. This energy can power entire galaxies, shaping their evolution and influencing the formation of stars and planets. In a sense, black holes are the engines of the universe, driving its growth and transformation. And then there's the possibility of using black holes as a source of energy. In theory, a civilization advanced enough could harness the energy of a spinning black hole, extracting power from its rotation. This is not science fiction. It's based on the principles of physics. In the far future, when stars have burned out and galaxies have faded, black holes may be the last sources of energy in the universe, sustaining civilizations for trillions of years. But black holes are not just about the distant future. They are also about the here and now. They are a reminder of the power and mystery of the universe and of our place within it. They challenge us to think bigger, to ask deeper questions, and to push the boundaries of what we know. They are a testament to the power of human curiosity and the relentless pursuit of knowledge. So what does the future hold for our understanding of black holes? The answer lies in the continued exploration of the universe through observations, experiments, and theoretical breakthroughs. New telescopes, both on Earth and in space, are giving us unprecedented views of black holes and their surroundings. Gravitational wave detectors are opening a new window onto the universe, allowing us to hear the collisions of black holes billions of light years away. And advances in theoretical physics are bringing us closer to understanding the true nature of these cosmic enigmas. In the end, black holes are more than just objects of scientific study. They are symbols of the unknown, the mysterious, and the infinite. They remind us that the universe is far stranger and more wonderful than we can imagine. They challenge us to keep exploring, to keep asking questions, and to keep pushing the boundaries of what we know. So as we look to the stars and ponder the mysteries of black holes, let us remember that the journey of discovery is never-ending. There will always be more to learn, more to explore, and more to wonder about. And in that journey, we may just find the answers to some of the deepest questions of all. Who are we? Where do we come from? And what is our place in the universe? Let's take a deeper dive into the mind-bending reality of black holes, where the universe's most extreme physics comes to life. These cosmic titans are not just static voids lurking in space. They are dynamic, violent, and incredibly active. They are the ultimate expression of gravity's power, and they are constantly reshaping the cosmos around them. But what makes them even more fascinating is how they challenge our understanding of reality itself. Imagine a place where time slows down so much that it almost stops, where space is twisted into a vortex, and where the very fabric of existence is stretched to its limits. This is the world of black holes, and it's a world that continues to surprise us with every new discovery. One of the most shocking revelations in recent years is the sheer scale of black holes. We've known for decades about stellar mass black holes, formed from the collapse of massive stars, and supermassive black holes, which sit at the hearts of galaxies. But now, astronomers are uncovering evidence of intermediate mass black holes, objects that bridge the gap between these two extremes. These elusive black holes, with masses ranging from hundreds to thousands of times that of the Sun, are thought to be the building blocks of supermassive black holes. They are the missing link in our understanding of how these cosmic giants grow and evolve. And yet they are incredibly hard to find, lurking in the shadows of star clusters and dwarf galaxies. Their discovery is a testament to the ingenuity of modern astronomy, using everything from X-ray observations to gravitational wave detectors to track them down. But the surprises don't stop there. Black holes are not just passive objects. They are active, dynamic, and incredibly violent. When a black hole feeds on matter, it doesn't do so quietly. The material spiraling into the black hole forms an accretion disk, a swirling maelstrom of superheated gas and dust that can reach temperatures of millions of degrees. This disk glows brightly, emitting radiation across the electromagnetic spectrum, from radio waves to X-rays. And sometimes, the black hole doesn't just swallow the material, it ejects it in powerful jets that shoot out at nearly the speed of light. These jets can extend for thousands of light years, carving out vast bubbles in the surrounding space and influencing the evolution of entire galaxies. They are a stark reminder that black holes are not just destroyers, they are also creators, shaping the universe in ways we are only beginning to understand. One of the most groundbreaking discoveries in recent years has been the detection of gravitational waves, ripples in the fabric of space-time, caused by the collision of massive objects like black holes. These waves, predicted by Einstein over a century ago, were first detected in 2015, opening up a whole new way of observing the universe. Since then, gravitational wave detectors have recorded dozens of black hole mergers, each one a cataclysmic event that releases more energy in a fraction of a second than all the stars in the universe combined. These collisions are not just spectacular to witness, they are also providing us with invaluable insights into the nature of black holes. For example, they have revealed the existence of black holes with masses that were previously thought to be impossible, challenging our theories of how these objects form and evolve. But perhaps the most mind-blowing aspect of black holes is what they tell us about the nature of reality itself. At the heart of every black hole lies a singularity, a point of infinite density, where the laws of physics, as we know them, break down. This is a place where gravity becomes so strong that it warps space and time into a state that defies comprehension. It's a place where our current understanding of the universe reaches its limits and where new physics must take over. Some scientists believe that the singularity might be a gateway to other universes or dimensions, while others think it might hold the key to unifying the forces of nature. Whatever the truth may be, the singularity is a reminder that there is still so much we don't know about the universe, and that black holes are the ultimate frontier of human knowledge. And then there's the question of what happens to information that falls into a black hole. According to quantum mechanics, information cannot be destroyed, but according to general relativity, anything that crosses the event horizon is lost forever. This contradiction, known as the black hole information paradox, has puzzled scientists for decades and remains one of the greatest unsolved problems in physics. Some theories suggest that the information might be encoded on the event horizon itself, like a cosmic hologram, while others propose that it might be radiated away as the black hole evaporates. Whatever the answer, resolving this paradox could revolutionize our understanding of the universe and bring us one step closer to a theory of everything. But black holes are not just objects of scientific study. They are also sources of inspiration and wonder. They remind us of the sheer scale and complexity of the universe and of our own small place within it. They challenge us to think beyond the limits of our imagination and to explore the unknown. And they show us that the universe is far stranger and more beautiful than we could ever have imagined. So as we continue to explore the mysteries of black holes, let us remember that the journey is just as important as the destination. Every new discovery, every new observation brings us closer to understanding these cosmic enigmas and to understanding ourselves. Black holes are not just the universe's most powerful objects. They are also a testament to the power of human curiosity and the relentless pursuit of knowledge. And in that pursuit, we may just find the answers to some of the deepest questions of all. Black holes are not just cosmic anomalies, they are the universe's ultimate enigmas, constantly challenging our understanding of physics, space, and time. Imagine a place where gravity is so intense that it warps the very fabric of reality, where the rules of the universe as we know them no longer apply. These celestial phenomena are not just theoretical constructs or the stuff of science fiction. They are real, observable, and incredibly influential in shaping the cosmos. And as our technology and understanding advance, we are uncovering more about these mysterious objects than ever before, revealing a universe that is far stranger and more dynamic than we ever imagined. One of the most astonishing recent discoveries is the role black holes play in the formation and evolution of galaxies. It turns out that supermassive black holes, which reside at the centers of galaxies, are not just passive occupants. They are active participants in the life of their host galaxies. When these black holes feed on surrounding matter, they release enormous amounts of energy in the form of radiation and jets of particles. This energy can heat up the surrounding gas, preventing it from cooling and forming new stars. In this way, black holes act as cosmic regulators, controlling the growth of galaxies and shaping their evolution over billions of years. This intricate relationship between black holes and galaxies is a testament to the interconnectedness of the universe, where even the most massive and seemingly destructive objects play a vital role in the cosmic balance. But black holes are not just galactic regulators, they are also cosmic time machines. According to Einstein's theory of general relativity, the intense gravity of a black hole can warp time itself. Near the event horizon, time slows down dramatically compared to the rest of the universe. This means that if you were to observe someone falling into a black hole, you would see them slow down and eventually freeze at the event horizon. their image fading into darkness as the light is redshifted beyond detection. For the person falling in, however, time would pass normally, and they would cross the event horizon in a finite amount of time. This bizarre phenomenon, known as gravitational time dilation, is a stark reminder of how black holes challenge our intuitive understanding of time and space. And then there's the mystery of what lies beyond the event horizon. While we can never observe the interior of a black hole directly, scientists have developed theoretical models to explore what might happen inside. One of the most intriguing possibilities is the existence of wormholes, hypothetical tunnels through space-time that could connect distant parts of the universe, or even different universes altogether. While there is no observational evidence for wormholes, the equations of general relativity allow for their existence, and they remain a fascinating area of speculation and research. If wormholes do exist, they could revolutionize our understanding of the universe and open up possibilities for interstellar travel that are currently beyond our wildest dreams. Another mind-bending aspect of black holes is their ability to create what are known as ergospheres. These are regions outside the event horizon, where space-time is dragged along with the black hole's rotation. In the ergosphere, it is impossible to stand still. Everything is forced to move in the same direction as the black hole's spin. This phenomenon, known as frame dragging, is a direct consequence of the black hole's immense gravitational pull and rapid rotation. The ergosphere is also a place where energy can be extracted from the black hole itself, a process known as the Penrose mechanism. This theoretical concept suggests that advanced civilizations could one day harness the energy of black holes, using them as power sources for interstellar travel or other unimaginable feats of engineering. But black holes are not just theoretical curiosities. They are also cosmic laboratories for testing the limits of our understanding. For example, the study of black holes has led to the development of the holographic principle, a revolutionary idea that suggests all the information contained within a volume of space can be represented as a hologram on the boundary of that space. This principle, which emerged from attempts to resolve the black hole information paradox, has profound implications for our understanding of the universe and could be the key to unifying quantum mechanics and general relativity, the two great pillars of modern physics. And then there's the question of what happens when black holes collide. When two black holes spiral toward each other and merge, they create ripples in space-time known as gravitational waves. These waves, which were first detected in 2015, provide a new way of observing the universe and have opened up a whole new field of astronomy. Gravitational wave detectors have already recorded dozens of black hole mergers, each one a cataclysmic event that releases more energy in a fraction of a second than all the stars in the universe combined. These collisions are not just spectacular to witness, they are also providing us with invaluable insights into the nature of black holes and the universe itself. But perhaps the most awe-inspiring aspect of black holes is their sheer scale. The largest black holes in the universe, known as ultramassive black holes, can have masses tens of billions of times greater than that of the Sun. These cosmic behemoths reside at the centers of the largest galaxies and are thought to play a crucial role in the formation and evolution of galaxy clusters. Their immense gravity can influence the motion of stars and gas across vast distances, shaping the structure of the universe on the largest scales. And yet, despite their immense power, Black holes are also incredibly elusive. They are invisible by definition, and their presence can only be inferred from their effects on surrounding matter and light. This makes them one of the most challenging objects to study in the universe, requiring a combination of cutting-edge technology, innovative techniques, and sheer ingenuity. But the rewards are worth it, as every new discovery brings us closer to understanding these cosmic enigmas and the universe they inhabit. So as we continue to explore the mysteries of black holes, let us remember that they are not just objects of scientific study. They are also sources of inspiration and wonder. They remind us of the sheer scale and complexity of the universe, and of our own small place within it. They challenge us to think beyond the limits of our imagination and to explore the unknown. And they show us that the universe is far stranger and more beautiful than we could ever have imagined. In the end, black holes are not just the universe's most powerful objects. They are also a testament to the power of human curiosity and the relentless pursuit of knowledge. And in that pursuit, we may just find the answers to some of the deepest questions of all. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Don't forget to check out our playlist for more incredible space content. Until next time, keep looking up.